Hello, this is Bill with my next cup of coffee and another book from my library. So today's book is Astronomy Through the Telescope, the 500-year story of the instruments, the inventors, and their discoveries, by Richard Lerner. This book introduces you to the many complex forms of one of man's most important scientific tools. It will help you share in the first glimpses of progressively deeper mysteries. I have been lucky enough to observe with the greatest telescopes for nearly 1,001 nights. I viewed a sky which was a storyteller. It was like Shuhner said, who entertained the Sultan with stories that never ended, needed to be continued another night. Stories full of surprising reversals of fortune, encounters with new friends, each with a new story. This magical entertainment was matched for me by high aesthetic and intellectual adventure. You too, I hope, will find astronomy and the history of the telescope as presented herein to be just such a stirring exercise for your intellect and imagination. So that's from the foreword by Professor Jesse L. Greenstein. First published in 1981 by Van Nostrum Reinhold Company. Copyright 1981 by Harrow House Editions. So, looking. Dates and destinies, measuring, beyond Saturn to the galaxy, the impossible achieved. So that's about when the early lenses had problems with chromatic aberration. So this is about the development of new lenses to reduce that problem. Professional lenses and amateur mirrors. Changing the rules. So I think that one is when the development of spectroscopy in photography. The brief reign of the big refractors. Glass mirrors are better than glass lenses. Limitations on the big reflectors. A new window on the universe. So that one's about radio astronomy. better detector is a shortcut to a bigger telescope. Tube radio telescopes are better than one. Onward and upward. Diversity. Not everyone has $10 million. So that chapter is about amateur astronomy and the future. Would be better if they give more descriptive chapter titles. So I'll put tabs here so I can find some of the better highlights of the book instead of just randomly flipping the pages like I did with the space technology book. So this is Galileo's telescope. So Galileo's trial by the Inquisition, held in Rome in 1633, was instigated by Pope Urban VIII. Galileo was sentenced to house arrest in his declining years as a punishment for his unbalanced presentation of orthodox views on the solar system. Only as recently as 1979 did the Vatican officially admit that Galileo's ideas were indeed true. This is Newton's reflecting telescope. Presented to the Royal Society in 1672. Crab Nebula above is an expanding cloud of gas, the remains of a supernova explosion that was seen and recorded by Chinese astronomers as a new bright star in AD 1054. However, the original explosion occurred in 3000 BC, and the light has taken more than 4,000 years to reach the Earth. And the Torquetum Rite from Peter Apian's Astronomicum Caesarum of 1540 was devised so that observations could be made directly in the celestial coordinates. It consists of a pair of sights attached to the uppermost pair of scales. Beneath this are additional adjustments that allow the instrument to be set up so that both the latitude angle of the observer and the 23.5 degree tilt of the Earth axis can be offset. When correctly set, the uppermost scales will read declination and right ascension, thus eliminating a great deal of the tedious arithmetic needed to convert altitude and azimuth readings into celestial angles. The solar system. That was when they still considered Pluto to be a planet. Herschel's largest telescope, left, usually referred to as the 40-foot, 12-meter, was completed in 1789, but it was not a successful instrument, as the site of Slough offered only about 100 hours a year of good observing conditions, and the telescope was too clumsy to exploit such brief opportunities. The last observation made with the telescope was in 1815. Joseph Fraunhofer, 1787 to 1826, with his spectroscope. Fraunhofer was a remarkable technical genius who made major contributions to the theory of lens design and the engineering problems of large telescopes. While working on the problem of how to eliminate chromatic aberration in lenses, the same problem that had led Newton to invent the reflecting telescope, Fraunhofer made fundamental discoveries about the spectrum of visible stars, the sun and the stars. Of visible light, the sun and the stars. So Rosse's 180 centimeters, 72-inch reflector at Bar Castle, popularly known as the Leviathan. It took 12 years to build at a cost of £12,000 using entirely local labor. The telescope was mounted on a pair of hinges fixed behind the main mirror. The hinges were at right angles, one to allow up and down motion, and the other side to side. Technically, this is called an altitude mount, and Rosse's telescope was almost the only instrument to have used the system. Somewhere is a description of this telescope. The photoheliograph at Kew, it was built by Warren D. LaRue and used for photography of the sun. It was used for the eclipse of 1860. So, above the arrival of the 91 centimeter 36-inch lens at Lick Observatory, no one knows why James Lick bequeathed the funds for the observatory. It is thought that Lick had never seen a telescope and was entirely ignorant of astronomy. The telescope was used in its early years for double star studies and the measurement of stellar velocities. In 1888, the lens was mounted in its telescope below at the Lick Observatory on Mount Hamilton. The 2.5 meter 100-inch Hooker telescope, which was completed in 1918. The complete instrument weighs a colossal 100 tons, and the majority of this load is carried by the two mercury floats enclosed within the big drums at each end of the polar axis. The telescope is driven by means of a 5 meter 200-inch diameter gear wheel at the lower end of the axis. The motive power is derived from the slow fall of a 2-ton drive weight. The yoke mounting of the instrument was chosen by Pease, Hale's colleague, for the great rigidity and strength. The disadvantage of the system is that the telescope cannot swing over to point along the polar axis, and so cannot observe the region of the sky near the pole star. The 1.2 meter 48-inch Schmidt camera on Mount Palomar. This instrument was completed in 1948 and first used to survey the entire northern sky. The plate holder takes plates 34 centimeters, 14 inches square, which cover a region of sky 6 degrees across, producing single photographs of as many as 1 million stars. In Britain, radar tracking stations above were used to detect the imminent threat of V-2 rockets, and this stimulated the development of radio astronomy. A view from directly above the 305 meter 1,000 foot aperture radio telescope at Arecibo. The telescope dish is fitted into a bowl-shaped valley and works as a transit instrument. So this Arecibo collapsed in 2020. So if you want to get regular updates on space-related news, subscribe to Scott Manley's channel. So Here's a video where he's analyzing footage of collapse of the Arecibo telescope.
Oh, it's Scott Manley here. Today, the National Science Foundation had a press conference where they revealed footage of the collapse of the large facility at Arecibo. And, well, I really kind of want to talk my way through all of this. This is a camera down in the control room, just showing how the whole thing went down, literally. That was footage by Carlos Perez, who'd set up a GoPro to record this in case this happened. Now, it's important to realise there were observatory staff on site when this happened. They were working in the safe areas as much as possible, but it wasn't without risk, and we are very happy to hear that nobody was injured during this collapse. I'm going to come back to this video, but I want to look at the second video, which is taken from a drone which was inspecting cables on Tower 4. The drone was being operated by Adrian, who was one of the technicians on site, and the drone would have been sitting like right there when things started to go wrong, and I've never seen a cable failure so close. Remember, these are 3-inch steel cables which are carrying hundreds of tons of load. It happens really fast. The center cable has a small break, then it pulls itself out of the socket, then the other cables start failing. The cable supporting the line feed is the last one to go. The drone then turns around and we get to see the platform falling into the side of the dish. We see material falling down, and yeah, everything is over in less than 30 seconds. I mean, there's still debris fluttering down and dust settling, but you can see the massive scars left in the dish and the debris that has been smashed on the mountainside. I don't want to turn this video into rubbernecking disaster images, but I've had a lot of people ask me to talk about this and talk about the dynamics and where it can go from here. But
so if you want to see the rest of that video, take a look at Scott Manley's channel. A radio telescope array at Westerbork, Holland above. One telescope at the end of the array can be moved on rails to give 11 sets of different separations simultaneously. There's the row of telescopes. The Space Telescope. The Space Telescope, which is due to be placed in orbit around the Earth by the Space Shuttle in 1983, will be able to observe, record, and measure astronomical phenomena in the absence of seeing effects and the faint light of the air glow. It will have 10 times better resolving power than ground-based telescopes and will be able to see objects that are 50 times fainter than those observable with any existing telescope on Earth. In addition, it will be able to observe in wavelength regions that are not detectable from the ground, particularly in the ultraviolet. So this book was published before the Space Telescope was launched. Next generation telescope concept. 6 telescopes of aperture 10 meters, 400 inch, together have the same light gathering power as one 25 meter, 1000 inch instrument, and an individual telescope of such an array is much easier to design and build than a single supergiant instrument. The light from the 6 telescopes can be combined either by mounting auxiliary instruments on all 6 telescopes and forming the resultant image from separate signals by addition in a computer, or the starlight can be combined at a central focus shared by all 6 telescopes. The need for a common focus for all 6 telescopes requires that the rays should be as compact as possible. In the design shown here, the telescope distance is 45 meters, 150 feet. So that's telescope to telescope distance. The author, Dr. Richard Berner, is a senior lecturer at the Imperial College of Science and Technology, England. His main research field is instrumentation in astronomy and astrophysics. He is the author of several reports on optical telescopes of the future and is visiting consultant to the Kitt Peak National Observatory Next Generation Telescope Group, currently working on the design of a large aperture balloon-borne telescope for far infrared astronomy. He also designs instrumentation for laboratory astrophysics and for ground-based rocket-borne and satellite astronomy. So that's all for this video. See you in the next one.